Well, basically it's just impossible. It cannot work in the vacuum of space. It's just impossible. Physically, it's impossible. Yeah.
So, what about all the scientists? Are they all lying, or?
The thing is that we have understood the word scientist wrong. Look, I'm a scientist. I'm a mechanical engineer, and I have a master's degree in technical physics. And I work as a research and development scientist. But when you say a scientist, you think that these guys are out there and they're just exploring the universe and trying to find the secrets of the universe. No, it's not like that. They pay us to do certain things, certain tasks. And if they don't pay me, I'm not going to go search those stuff. Even if there are some people like me who do think about it, the thing is that since childhood they tell us that the rockets do work and the NASA is sending stuff up into the space. And so you're just programmed since childhood. You're not going to be questioning that program. And even if you do question that program, people will laugh at you. People will judge you. They think you're stupid. So you end up losing your jobs and friends and stuff. So the scientists, they don't do that to themselves. It's a stupid thing to do. Even if it's the truth, but you just don't do it. The reason that you do think that rockets work in the vacuum of space is because of the third law of motion. The third law of motion states, it says that for every action there is an equal and opposite reaction. So it's really easy to test that. Let's put this into action. An action is, for example, I'm going to start punching now. So I'm punching and I don't feel any reactions. Do you see reaction? I don't feel any reaction. But then I start punching the wall. I feel the reaction. I mean, you can try it. You feel the reaction. If it starts hurting, and if I punch harder, it's going to bleed, and if I punch even harder, it's going to break my bones. So it seems like the third law of motion, when in order for you to get the reaction, the equal and opposite reaction, you have to apply your action on something. If it's nothing, then you don't get the reaction. For example, if I'm now pushing myself. Okay, I'm pushing my hand, and no reaction. I don't feel any pushback. But then I push the wall, and I feel the pushback. So you cannot just push nothingness and expect something to happen. There has to be something.
But what about if I, for example, in a skateboard and I have a bowling ball, let's say, and I throw it, I go backwards. So
look, when you are standing on a skateboard and then you are pushing a 15-pound bowling ball, that 15-pound bowling ball has a static inertia. It means it wants to stay static. It doesn't want to move. So when you're pushing that, you're pushing yourself back. If you think that the third law of motion works in these kind of cases, then you can just throw a pen. Just see if you go backwards when you're throwing a pen. Throw a balloon, throw a light object. And yeah, cool. So you have a balloon, and you can push the balloon and see if you go back. Or a ping pong ball. It doesn't happen. The same thing when you're pushing a car. You know, have you ever tried it when a car is broken and you're pushing it? At the beginning it doesn't move. It's heavy. And then after some time it just moves slower. It got out of that static inertia. It's now moving, so it's easier to push it. It's not that difficult. So in order to get this reaction, you have to push against something. Otherwise, it's not happening. This guy, the reason it goes up is these high velocity and hot gases that exit the exhaust of the rocket engine will push against the ground first, and then it takes off and it goes up. The air down here becomes thinner. But even if it's thinner, the speed of these gases will turn that thin air into a barrier. You know when you're, for example, driving in the highway and you stick your hand out of the window and you feel this pressure, and the faster you go, the more pressure you feel? That's the same thing. Even if your hand is small, when the speed is high, the pressure increases. It becomes a barrier. The same thing in here. It pushes these hot gases and high velocity gases down. Even if it's thin, it still creates a barrier out of them. So as long as there is air or thin air, the rockets do work, but when it goes out in the vacuum of space where there is nothing, then it's nothing. You can push it and nothing will happen. This is easy to test actually. Look, you can get a simple drone and just put it on the ground, accelerate it, so it lifts up from the ground and hovers at 20 centimeters. Do not touch the accelerator anymore. Just put a cardboard sheet under the drone and just lift it up. When you lift it up, the drone starts coming up also, and it maintains the same 20 centimeter distance between the bottom of the drone and the sheet. And the moment you take the sheet out, you take it away, the drone just drops down, hits the ground, and the hitting the ground happens due to inertia. Hits the ground, comes up and maintains the 20 centimeter distance. So based on these observations, based on what I just showed you, pushing, punching, and the drone, which I can show you actually, we can go outside and I can demonstrate this. It's impossible for the rockets to work in the vacuum of space. It just doesn't happen. The paired law of motion happens when you apply your action on something and that something can react to you. When there is nothing, there is no reaction. Simple as that. Yeah. And the thing is, many people say that the rockets don't work in the space because there is no air. No, you're just misunderstanding it. They're carrying their own liquid fuel and they're carrying their own liquid oxygen, so they don't need air. That's not the problem. The problem is this pushing act that you have to push on something.
So you will say that they don't move. They cannot move up in the outer space.
When you're in a vacuum, no. This doesn't produce any thrust.
Even if it's like it's producing its own fuel, it wouldn't move.
It wouldn't move at all. Because as I said, you have to push against something in order to feel that reaction. And back here is a vacuum now. I mean, everywhere is a vacuum in the space. So there's nothing to push against, and duh, it's just not happening. So yeah, we can actually go outside and try the drone thingy. So I'm not a good pilot, so I have to try to balance it first, but let's try our best. Okay, there we go. So as you can see, I'm not pushing the gas anymore, and we go up. You see, I'm not touching the gas, and then it comes down. You go up, as much as you want, and there you go. And the 20 centimeters is maintained, and then we go up again. You see, it needs something to push against, otherwise it drops. Yep, simple as that. Based on this, you can see rockets just cannot work in the vacuum of space. It's done. There is nothing you can say about this. It's over.